Hello and welcome to Unprofessional Engineering. My name is James.
And you got Luke.
Luke, we're tackling a topic of the future, machine learning.
Is it really the future, James? Because I feel like it's kind of here now, right?
The future is today, and machine learning is here with us.
That was deep.
I try, I get that a lot about my intelligence and deepness and all that stuff. Okay, so what is machine learning, Luke? Do you have a definition off the top of your head?
I have one right off the top of my head. So machine learning are algorithms that used statistical patterns in massive amounts of data.
Massive.
And that massive amounts of data. And this can be anything from numbers to words to images to clicks, whatever you happen to have. And a machine uses that data to basically learn how to perform some task. It can be a physical task. If you think of like a self-driving car that corrects itself to stay in the line, or it can be maybe a recommendation on Spotify for the next song to listen to. So it could really be anything from something that happens on a software side or something that would happen on a physical side, like a self-driving car.
That was
beautiful. I'm
Luke.
sure you have a much more detailed one, just again off the top of your head, if you wanted to expound.
No, I think you really nailed that. But I do have a fun fact about machine learning, if you're open.
Let's hear it.
So even though machine learning is kind of new to most of us, I know it's gotten kind of popular and trendy in the last few years, but it was actually invented back in 1986 by Jeffrey with a G Hinton. He's considered the father of deep learning.
Do you like guys that spell their name Jeffrey with a G? Or do you have an issue with them?
No, I guess I'm okay with it. Is that kind of like a British versus American thing, or what?
I always thought it was like Geoff.
Geoffrey. Ask Jeeves. Do you remember Ask Jeeves?
I do remember
I think that was a J, but still, I think it's kind of funny.
Alrighty. Off track, sorry.
Sorry about that. Yeah, so he is considered the father of deep learning. And so then I had to Google machine what deep learning actually is. And so apparently deep learning is machine learning on steroids, is what I got out of it. So it's a technique that gives machines an enhanced ability to find and amplify very small patterns. So something that, like, if we were looking at something, we wouldn't really pick up on it, but because machines are smarter than us, or at least they have more computing power than we do, they're able to pick up on these very small patterns. So this technique is called a deep neural network. Deep because it has many, many, many layers, Luke, of simple computational nodes that work together, kind of like a brain. So deep learning.
So the difference, and I can give you a slight difference.
I would love that.
So you mentioned a little bit of it. So machine learning is algorithms, and it basically improves performance based off of the data. That's all it does. So the one example was you show a computer a picture of a dog, and the computer has to identify it as a dog. It gets it wrong, so you tell the computer that you're wrong, it's not a dog. Well, the next time it sees a similar image, it knows it's a dog or a cat or whatever.
You're for sure stealing my thunder from later on.
Totally
from examples we definitely stole from the same video.
I did not want to go into detail. But deep learning, and so this feels like Terminator, and I'm going to make many Terminator references in today, I'm sure. But
it was ahead of its time, Luke.
Oh my goodness gracious! So this is like, I mean, just using the term multi-layered neural network. I mean, that neurons is what they're talking about, like your brain. And what this does is this uses cloud computing. It uses clusters of computers, and what that does is rather than a single computer making a decision, there are literally potentially thousands or hundreds of thousands of computers or a cluster or the cloud looking at that data. And what it does is where machine learning can't make a decision. So machine learning has like two options, and they're very clear options to choose one or the other. Well, what happens when that decision falls somewhere in between those options? That's where deep learning comes in. It looks at super minutia level of detail and says, okay, this matches, B more than it matches A, and can make that decision, where machine learning just doesn't have that capability just because of the computing power that
Right.
is available to it.
Right. So I have an example that is kind of cool. I think it's something that everyone can relate to, and it kind of gets into what you're talking about, where you have the machine learning, and then it gets a little bit deeper into the deep learning. So let me run through that real quick, and then we could start breaking down the different types of machine learning that there is out there.
Gotcha.
So let's say there's a guy. We'll call him Luke. Does that work for you?
That works for me.
All right. Luke likes to listen to music, and either he likes songs or dislikes songs. So think about using Pandora or Spotify, where, you thumbs up or thumbs down something, and that kind of feeds information to the system as to what does Luke actually like. So now we normally think of it as just like Luke likes this song, but really what's being factored in are a whole bunch of different things, such as the tempo of the song, the genre, is it a male or female singing, the tempo, the intensity, all sorts of different factors come into play when you're looking, especially at the deep learning portion of this. So when you plot all of these factors together, you're able to learn about the type of music that our good friend here, Luke, actually likes to listen to. So in our example, we're going to look at how we would plot tempo versus intensity. Did you watch this exact video, Luke?
I may have watched the exact same video.
Okay, good. So we're on the same page here. So Luke likes really fast tempo music, right?
Yes,
That's
I do.
Where you say yes. Okay,
yes,
thanks.
Yes. It's called country rock, I believe.
Luke
is
likes
what I listen to.
Fast tempo, high intensity country rock music.
Yep.
Do you actually listen to country rock?
No.
Oh, okay. Good to know. So if a new song shows up that matches this really high intensity, really fast tempo music, Luke's going to like it, and he's going to give it a thumbs up. Now, to go a step further, something like Pandora will start to recommend songs to Luke based off of the learnings that it's had in the past. So the likes and dislikes that he's fed it, it's now going to determine what he's going to like ahead of time and feed those songs up to him more often. So to take this a step further, if Luke likes another song that has, let's say, a medium-paced tempo or intensity, it wouldn't fall in that same cluster of high-tempo, high-intensity music. It would fall somewhere outside of that. So I don't know if Luke's going to like that one or not. And this is where the k-nearest neighbors algorithm comes into play. So this is... Stop laughing.
I was so planning on asking you if you knew what this was, and we clearly watched the exact
I
same
did.
video.
No, this is just from my research that I've done on machine learning for my thesis.
Top of your head.
No,
research.
no. I mean, it was years and years of thesis when I developed machine learning.
Okay.
When I was at Carnegie Mellon.
K nearest, I believe, is where you were.
K nearest neighbors algorithm. So this is one of the many algorithms that's used for machine learning. It's just a pretty simple example to use, though. So this basically is saying that if there's more songs close by to the medium tempo one that Luke likes, he's probably still going to like this one. Versus if it's closer to the ones he doesn't like, he's going to not like that. So all of these are clustered together. And machine learning is able to then figure things out as to, even if it doesn't fall in the exact genre or area that Luke likes things, he's still probably going to like this one or probably not going to like this one. And depending on the number of likes and dislikes, the more data it has, the more accurate these gray area points get revealed.
So I'm going to throw you a curveball here, James.
I don't like curveballs.
Are you
Luke.
ready for the curveball?
I'm more of a two-seam fastball guy, but yes.
I don't know what that means because I'm not a sports baseball person.
Sorry.
But the problem that I have is me and my daughter share our Spotify account.
Ooh, yeah.
And it goes from, me on, my contemporary Christian music and Pantera and Van Halen and, that kind of, that's what I listen to. Very broad. And then my daughter listens to Lizzo and somebody named Bill Eilish.
Irish?
I think it's Billie Eilish. Billie
Irish. Is Billie Irish the one who wrote into us as part of our Irish fan base?
I don't know, but there's someone named Bill or Billy. I don't know who it is. I'm fairly certain she's pretty popular.
Billy's a girl?
I'm pretty sure Billy's a girl.
Oh, neat. Okay.
So the problem is my Spotify is like all over the place. Like I think I
Yeah.
break it sometimes. Like I'll launch it and I'll look and it'll be like Lizzo and like Post Malone, some guy with a bunch of face
Yeah,
tattoos,
he
I
has a
think,
lot of
and his
tattoos.
name is Post. I don't get that, but all right.
I wonder if
But
it really
then,
is.
but then it recommends like Hillsong United, like some kind of Christian, contemporary band, or it
Okay.
recommends Pantera or like Van Halen. So I imagine like when you share logins the way we do, like she listens on her phone, I listen on my phone, it has to totally throw off those algorithms because it's
Oh, yeah.
never accurate.
Absolutely. The same thing goes with a shared Netflix account. Like my wife and I watch different shows, but we use the same login because we're lazy. And
Mm-hmm.
the same, it's like, why do I want to watch, I don't know, some
The
show?
Great British Baking Show.
I for sure do want to watch that. I love Mary Berry. But anyways, yeah, that's a good point, Luke. Really throws things off. Maybe you should get your daughter her own account. Think about that.
Well, you're allowed to stream, I think, Spotify on one device at a time. So as long as we're not in at the same time, we're good.
Okay. So anyways, before we move on, I think it's time that we take a break for a word from our sponsor.
It's got to be Spotify with all the kudos I just gave them.
I gave Pandora a few shout outs
Pandora.
too. You're a Spotify guy then?
I used to be Pandora, but I think I like Spotify a little bit better.
Okay, I actually just started making Spotify lists myself. Anyways, we don't have a sponsor this episode, boo, but we do have a shout out, and that goes to Joshua B. He's a senior at Fort Cherry High School. Luke, do you know where Fort Cherry High School is?
I know exactly where Fort Cherry is. I got a couple kids I know that actually go to Fort Cherry. One of my buddies, his two sons go to Fort Cherry. How cool is
Awesome.
that?
Yeah, so it looked to me like it's a little bit outside of Oakdale, which
Yep.
is the closest spot on the map that I
No,
recognize.
I actually picked these. We actually had to go. We went fishing one time, and I went out to Fort Cherry High
nice.
School and picked them up.
Very nice. So, for those of you who can't tell, this is close to Pittsburgh, our
Very.
hometown. So, Josh is going to be, I don't know if I can call him Josh, but I'm going to. He's going to be going for mechanical engineering at Robert Morris. And he's also graduating top of his class. So, congratulations to Josh.
Robert Morris Mud Duck, way to go!
Yeah, the Mud Ducks. What are they, the Colonials or
I
something?
think they're the Colonials.
I think so too. So yeah, thanks a lot, Josh, for writing in. I sent him some advice. Hopefully he doesn't take it because I am just not the one to be giving advice, especially to someone
Clearly.
that smart, right?
Clearly.
So if you want to write in and say hi, if you want to request some stickers, if you have some topics for us to cover, if you want to tell us what machine learning actually is, why don't you email us at unprofessionalengineering@gmail.com.
Make sure you subscribe. Make sure that you review. Make sure that you like. Make sure that you share. Yell at your Google and or Alexa device
all
to
that stuff.
play Unprofessional Engineering podcasts.
Yeah, all those things. Okay, let's move on, Luke. Do you want to get into the 3 different types of machine learning?
Yeah, so real quickly, at a high level, there is what's called supervised learning. There is
That's what you need.
unsupervised. I need supervision all the time. Because definitely me being unsupervised is a bad thing. So there's supervised, unsupervised, and then this last one is the creepy one, I think, is the reinforcement learning. Like, it's a computer. I have to give you like positive or negative reinforcement. I mean, that one's a little weird to me. So I'll take the first one, and you can maybe take the second one. So the first one is what's called supervised learning. And the way supervised learning works is really similar to what you just said, where there's a user, me, and that supervised learning, like it's essentially labeled. So there's information that the computer or the machine can understand based off of a description, some kind of labeled data. It can very easily categorize that data because there was almost like pre-input created. So we identified things ahead of time. And the idea is, so the example they give is, think of this as something like a sniffer dog that hunts down a target.
Is that the technical name, Luke? A sniffer dog?
I think sniffer dog.
I love that.
Hunts down targets once he already knows the scent that he's after. So he kind of has to know what he's after first. So it's been identified. So if you think of like a drug dog, right? So they got to learn to smell, the pots, the marijuanas, all that, illicit drugs. And or bombs or whatever it happens to be, and he has to learn that first. So he has to. They identify specific drugs or materials but once they know that, because it was labeled, then they can proceed and do the task. So that they've learned that way. The other way, too, is every time you press play on a Netflix show, this is kind of your thumbs up, thumbs down example you gave, is if I hit play on Netflix, it knows that I want to watch that show. And then the next time I launch Netflix, it's going to show up as a recommendation. And so just keep that in mind, folks. If you don't want your spouses or significant others to know the types of shows you're watching, don't hit play on shows and be like, oh, I'm just going to watch 5 minutes of this, because it's going to show up as a recommendation next time. So keep that in mind.
That's solid advice.
That is supervised learning.
Would you consider Indy to be a sniffer dog?
No, she's about as dumb as you come.
Aw,
she's a great dog.
Yeah.
She's obedient, but she's not very good at learning new things.
Okay, very well. Maybe that's because she's had too much unsupervised learning.
Exactly.
See what I did there?
I see what you did.
Okay, so unsupervised learning, and this is going to go off of certainly not the video that we watched. So the
Certainly
example
not.
that I watched was talking about cricket players. And I know nothing about cricket. So if we
Yeah.
have anyone listening that could explain cricket to me in like maybe 3 minutes, please email us and let me know about it, because I'm really interested in cricket. I've watched it on TV a few times. It makes no sense.
You know what we should do? We should do a podcast on what we think cricket is, just as kind of a spoof. And then basically the billions of people in other parts of the world, because apparently cricket is bigger than anything else in other parts.
It is a big deal, yeah.
They will hate us.
Do they have googlies in cricket?
I don't know what a googly is.
I hope they do. Anyways, so in my example, Luke, we're going to talk about baseball, which also might not work for you, but I think for a lot of other folks it might.
As long as you
make
get touchdowns,
sense.
you're good.
Exactly, and hole-in-ones. So let's say we have a bunch of data for all of our baseball players, like all sorts of stats. And let's say we're particularly interested in RBIs, which, Luke, that is runs batted in for you not so baseball inclined people, as well as strikeouts thrown. So those are our two columns of data, along with our player names. We stick all of this data into a machine somewhere, and it jumbles it all, and it learns from it.
Bleep, blop, bloop, 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 bleep, blop.
That's exactly what it does.
That's what it sounds like.
You remind me of like Scooby-Doo or something back in the day where they'd have a machine. Yeah. So the machine, computer, whatever, plots this data with the RBIs on one axis and the strikeouts on another axis, where it can then clearly show people that are like good batters, like the people hitting home runs and getting hits, and the people that are throwing lots of strikeouts. So it can then group everyone as batters or pitchers, because of course the pitchers are the ones throwing the strikeouts. We didn't have to provide any labels like Luke talked about in his example where he was talking about supervised learning. The unsupervised learning doesn't require labels, but the machine can still group this data into these different segments, and this therefore makes the data unsupervised.
So how would they categorize me as someone who never gets off of the bench?
I don't want to be mean. I was actually going to say someone who's really good at pitching and batting. So
no, I was very good at warming the bench when I played. My illustrious football career, I was very good at warming the bench.
Have you ever tried softball since you were like an adult?
I have tried softball. We had a church league one time,
yeah,
and clearly my ability to have the hand-eye coordination to even hit a softball has degraded severely since like high school time frame.
I wasn't the best baseball player because I was kind of small, so my strike zone wasn't real big. It was really boring because I got walked all the time. But I did try and play softball, with my friends, and I found that my golf swing has just completely taken over. So I swing a baseball bat like a golf club now.
I gotcha.
All right, so before we move into what reinforcement learning is, or reward-based learning, let's take a break for this week's Luke's Rant.
So I'm keeping it directly related, and I may have mentioned this rant before. I'm actually pretty positive that I have, but I don't think it can be stressed enough. This idea that we have these devices. So we have computers and iPhones and smart devices sitting in our house, and I have conversations, which I think are in private, James,
I think.
with my wife or my daughter. We're talking about a vacation we're thinking about, maybe something we want to buy at the grocery store, whatever it happens to be. And the next thing I know, I never Googled this, because I get the way Google works, right? I get the way Facebook works. Like, if I go somewhere, it's going to recommend it, or if I search for something, it's going to come up in recommendations. I totally get, if I interact with my phone, my device, I actually want it to give me recommendations. That's kind of cool. But when I don't interact with my device, when I don't type something in, when I don't ask Alexa a question, and I get recommendations for things that I spoke about in my house or talked about in my house, that is just, I feel like that is the creepy, deep learning, artificial intelligence, machine learning, whatever you want to call it, that is just totally freaks me out. And I know you and I've talked about this. You've had this happen to you before.
Yeah.
I've talked to a bunch of different people, and I'm sure there's security things you can do for like shutting your microphones off and stuff like that.
Do you think that's what it is? Is that the microphones, like your Alexa or whatever, is picking up on it? Or do you think it's that you maybe looked for something kind of related and somehow it pieced together like the search A and search B that are kind of related and slammed them together to give you this offering?
So you're probably right. I mean, if you think about that machine learning where there's those two clusters where it can clearly give a recommendation one way or another, but there's a gray area and it just kind of knows. I mean, maybe it's that smart. I personally think the microphones are listening on our devices.
Or aliens.
Or it's aliens and mind control. I mean, one or the other.
So I fully support both social media and other digital marketing options for targeting people with ads, because otherwise I would have no job. So I appreciate it. All right. Well, I agree with you, Luke. It's creepy. Ready to move on to reinforcement learning?
Yes.
All right. Do you want to talk about this one?
I will, and then you can add anything to it that you like. So here's how reinforcement learning works. So as you're working on your computer, when the computer gives you a wrong answer, you point at it and shame it and tell it, right? Isn't that like
basically,
you give it negative reinforcement, just like all good parents do.
Yep.
Whenever it misbehaves, you yell at it. I joke, that's not good parenting. No. So I kind of mentioned it before. Reinforcement is it's similar to supervised learning, because you have to tell it that it is either right or wrong. So there's definitely some human interaction. And the example I gave was the dog. So you have a picture of a dog, you tell a computer, identify what this animal is, and the computer says it's a cat, and then you tell the computer, no, it's not a cat. No, you stupid computer.
Right.
It's a dog, and then the next time it sees something similar, it's going to say, oh yeah, okay, it's a dog. And what you do is you show it just hundreds and hundreds and hundreds of thousands of different dogs, like ugly dogs, big dogs, little dogs, all the dogs. And then eventually, with really high accuracy, it's going to be able to identify dogs based off of the reinforcement that you've given it.
I think that's what's really interesting about it, Luke, is that, dogs are different. Like your dog and my dog are very, very different dogs.
If we were on a different planet, they'd probably think they were different species.
Absolutely.
Like, they're vastly different size. They look totally different.
Yeah. So it's interesting that it can do that and then still differentiate, say, my dog from a cat, which I think they're pretty similar, but somehow it's that smart that it can keep all of that data figured out and know which
because
one's
like
which.
If you think of it, a cat's furry, a dog's furry. A cat has 4 legs, a dog has 4 legs. They have tails,
Usually.
they have ears, they have whiskers. Yeah, usually they have whiskers. I mean, it's just like, I don't know.
I agree. All right. Anything else you wanted to talk about in those methods?
Not that I can think of. I got a whole bunch of like day-to-day applications. I'm not sure if
That's
we're
what I
ready to
want.
talk about
Yeah,
those.
that's exactly where I was going.
Alrighty.
And just to be clear, we were going to that on the same time, even though it wasn't part of the video. So there.
I know.
Boom. Let's hear what you got.
So these are in no particular order because literally there's probably thousands and thousands of applications.
Yes.
So day to day, the first one I mentioned is any kind of recommendation you get on any service. So whether it's Facebook, Twitter, Insta tweets, Tick Mocks, Spotify, Pandora, whatever it is, anytime you get a recommendation, that is machine learning in the background, making a recommendation based off of what you've done previously and what they think you want to listen to.
I like that one. One that I think is really creepy, Luke, but a really awesome application is like your Alexa, and I assume Siri as well, but I know Alexa for sure, has the ability to do voice recognition. So if I talk to my Alexa device versus...
It can? I didn't know that.
Yeah, it responds to me when I talk to it, and it responds. It knows my wife is talking to it when she speaks to it.
I didn't
so
realize
it's
it made a
really
difference.
crazy. And then also the ability to answer questions. I know it's like a compiling of data or maybe a scouring of the internet or whatever, but still super cool machine learning application.
So we were super bored like day one into the quarantine here.
Sure.
And we saw on our Alexa device, it says play a game. And we were just like, oh, let's play. So we went through and picked a game. And it was this Guess the Animal game on Alexa.
Oh.
And what it does is it says, think of an animal. Like, and this was pretty creepy. It says, me, think of an animal, not Alexa. So I thought of, giraffe. And then basically Alexa asks all these questions. So basically it's using that reinforcement learning.
Yeah.
It says, does the animal have 4 legs? Yes. Does the animal have stripes? No. Does the animal have feathers? And you answer all these questions. And so we all took turns doing it, me and my daughter and my wife. And every single time in under 10 questions, Alexa could guess the animal.
That's pretty cool.
Yeah, it was pretty crazy.
I love that. Another cool machine learning feature, application, we'll go with application, would be, well, it's less cool for us, but like something like Uber and Lyft. I love Uber and Lyft and I use them a lot, but what I do hate is surge pricing. But this is all about machine learning because these platforms understand when rush hour is going to be, regardless of what city you're in. How long rush hour is. So in Pittsburgh, it's probably, I would say, 3 hours long. So it knows to charge us more money at that time. And just all sorts of factors that go in. What part of the city you're going to be going to from one place to another versus if you're going to another spot, your surge pricing might be different. So that sort of machine learning is great for the people driving, not so great for us.
Next one is any kind of weather prediction that you see, like anytime you're watching the weather, they're basically using probably a combination of deep learning and machine learning.
So it's not just Joe DiNardo telling me?
Well, back in the day, I loved it when it was Joe, because Joe would like look out the window of his helicopter, and say, "Yeah, it's raining. We're gonna have rain today." Nowadays we get Steven. Right. Nowadays we get Steven Cropper with this super sophisticated, screen, and then what he says never happens. Sorry, Steven.
If you want to check out how they predict weather, we have a whole episode on that. So go check it out. Yeah,
we do. But yeah, so all of those models that you see, those images of like the clouds coming in, that's all deep learning, machine learning, basically taking data from the National Weather Service and different locations and compiling it together to generate that. So that's another example of machine learning.
The last one that I wanted to talk about, because I love it and appreciate it, would be fraud detection for your banks or credit cards. They use this machine learning to understand what your typical like purchasing trends are or places you would typically be buying things. And if something's way off kilter, they're going to flag that and freeze your bank account or your credit card account, or maybe just reach out to you directly to make sure that it was you purchasing something in that location or at that store. So certainly appreciate that. Did you have any others that you wanted to talk about?
The only other one that was kind of interesting to me was dangerous jobs.
Ooh.
And this is kind of I think the cool part of machine learning. So there are tons of jobs that involve robots, and there's all these creepy videos of like robots doing backflips and like opening doors, and they kind of look like they're from the movie Terminator, and they're getting more sophisticated. But there's a lot of jobs. So perfect example is whenever Fukushima happened. This was the nuclear reactor that had a meltdown and yada, yada, yada. They had to send robots in.
That was the typhoon caused one, right?
Yeah.
Okay.
And a lot of this robotic stuff was probably human controlled with like a little remote control doing some work. But there were portions of the jobs where it would the robots and the sensors and all the things that were collecting data, it was actually mapping, radiation hotspots in the facilities. Wow. And it was recording all that data and interpolating it. So it was this combination of you have a physical machine robot collecting data, but then that data is pushed over to, a server or, a cluster PC or something like that. And it's taking that data and making something, real out of it that you can analyze and review. So, but a lot of it is, taking dangerous jobs and basically automating that with a machine based off of, if this happens, don't do this. And I think of like RoboCop whenever I think of this one. And, if you remember in RoboCop, he had all like these advanced directives and, he can't hurt people and everything has to be for the good. But he was basically machine learning. And if you remember in RoboCop, I'm fairly certain he learned to love in the end.
That was really a beautiful story, wasn't it?
It was.
Yeah, I agree. All right, so the last thing I had to talk about was different companies that use machine learning that you might not think about, but it's really what we would call filler material. So if you're interested, why don't you go check out how places like Yelp, Pinterest, Google, IBM, and Salesforce use machine learning. We think about Watson when we talk about IBM and how he wins at Jeopardy, but they're doing a lot of really cool machine learning with Watson. So maybe go check that stuff out. Anything else you wanted to add in, Luke?
That's all I got.
Awesome. Hopefully you all learned something about machine learning. Pretty good, right? No? Okay, I guess not. If you enjoyed it, let us know. Email us at unprofessionalengineering@gmail.com. And until next time.
See ya.